Welcome back, Math 10. Today we're going to look at conversions within the SI system, or the metric system. Okay? So if you remember, metric is what most of the world uses, and imperials were British and the United States uses. Okay? We also use a bit of imperial as well because of our heavy trade with the United States and our heavy trade with England. So let's go on right here and just analyze this table for a bit. So if we look at this, we have the symbol. G is for giga, M is for mega, K is for kilo, H is for hecto, DA is for deca, D is for deci, centi, milli, so on. So this is my first. And all of these, they kind of use scientific notation to do this. So 10 to the power 9, 10 to the power 6, 10 to the power 3, 10 to the power 2, 10 to the power 1, all the way down to 10 to the power of 9. Okay? So now it says complete the following. 1 gigameter is equal to how many meters? Well, that is going to be 10 to the power of 9. So 1 multiplied by 10 to the power of 9, which is equal to 1 with 9 zeros. Okay? The next one, 1 megameter, is 1 multiplied by, whatever this is, 10 to the power of 6. Okay? Which is the same as, that's it. The next one is 1 kilometer. Well, we know that is 1,000, 10 to the power of 3. So that's 1 times 10 to the power of 3, which is the same as 3 zeros. That's how many meters. Okay? Now, let's take a look at 1 centimeter. Is how many meters? Well, this is the exact opposite. It's 10 to the negative 2. So it's 1 multiplied by 10 to the negative 2. Okay? Put that into your calculator. You're going to end up getting 1 millimeter. Well, that's 10 to the negative 3. Because basically, 1,000 millimeters equal a meter. 100 centimeters, centi as in 100, equals a meter. Think of the millennium. The millennium was milli, 1,000. Okay, 1,000 years. 1,000 of these equals a meter. So it goes on like that. So this is the same as 0.001. Next one is micrometer. So that's 1 multiplied by 10 to the negative 6, which gives me 0.12345, Okay? And the last one is nano. So that's 1 times 10 to the negative 9, which is equal to 0.1234567, and then we have 1. Okay? So it's always just 1 less than this. Okay? So now, let's take a look at liters. Now, liters is kind of the same thing as grams. So 1 liter is how many milliliters. So now we're working in reverse. We want how many liters are in a milliliter. Well, I'm going this way. 1, 2, 3. So that's 1 multiplied by 10 to the 3, which will give me 1,000 milliliters. Okay, we're going the other ways. Okay? Here, we're going to go how many grams are in a milligram. Well, that's going to be the same thing, which is, okay? And how many kilograms are in a gram? Well, that's, so basically, anytime I go this way, that's the difference of what we have to do. This is plus 3 10 exponents to go that way. Okay? Every time we go this way, we have to multiply by a positive exponent. Anytime we go that way, we multiply by a negative exponent. So 1 milliliter equals how many liters? So milliliter, right here, to liters, we go that way. So that's going to be 1 multiplied by 10 to the negative 3. So we're going in the wrong direction. We're going from milliliters to liters. Okay? If we're going this way, they get bigger, that way they get smaller. Now let's take a look, which is 0.001. Now, milligram to grams, that's again, we're going from here and we're going that way. So we go 1 times 10 to the negative 3, which gives me 0.001. Then grams to kilograms, well, that's from here to there. So that is 1 times 10 to the negative 3, which is equal to 0.001. Okay? So anytime we're going this way, it's going negative. Every time we go that way, it's going positive. Okay? All right. So we're going to look over a few different methods on how to use the SI and convert metric. Okay? So one of the biggest advantages of the metric system is everything's on a decimal system. Okay? So it's how many units away. So the first one here, we're going to use using the metric number above to complete the following for each of these. So 1 meter is equal to, well, if I have this here, there's a meter. Oh, that's milli, 1 unit, 1 meter, same as how many centimeters? Goes over this way. So that's like times 10 to the 2. So that's 100. 1 millimeter is equal to, this is like times 10 to the negative 3, which is the same as moving the decimal over 3 times that way. So 0.001. Okay, next one, 1 meter is equal to how many milliliters? Well, this time we have to move the decimal that way. So we're moving the decimal. This is how many times we move the decimal over. It's like 1, 2, 3. Okay, so that is going to be 1,000. It's just a moving of the decimal. That's all that one is. Let's take a look at example number 2. It wants us to convert the following measures to what it states. So 7.5 meters to centimeters. So I'm going to use my linear table here to help us. So this is a neat little way of doing it. So we have my unit is meters here, and we want to go to centimeters. So I move the decimal over 1, 2. So the decimal, right there it is, moves over 1, 2. So I have 750 centimeters. Okay? Let's take a look at my next one. We want milligrams to kilograms. So milli to killi. So we move over 1, 2, 3, 4, 5, 6. So we have to move this decimal over. There's an imaginary decimal there, right? Because it would be 0.0, 1, 2, 3, 4, 5, 6. And there's a 0 there. So we have 0.72350 kilograms. See how that works? We're just switching our direction. So the last one we were doing multiplying by our scientific notation. This one we're just converting by shifting the decimal. So we have micrometers to nanometers. So micro is right here, and we want to go to nano. So we are going 1, 2, 3. We move the decimal over 3 places. So 1, 2, 3. So we have 3, 2, 5, and we move it 1, 2, and then 3. And that will be nanometers, just like that. Okay, does that help? All right, let's take a look at my next example. Convert the following, leaving the answer in scientific notation. So now it wants us to leave in scientific notation. If you don't quite do that, don't worry about it. But try your best to get the scientific notation, because you're really going to need scientific notation when you're taking chemistry, biology, and physics. So it's a good practice here. So we have 12 kilometers to millimeters. So we want kilometers to millimeters. So how many times we move this? We move this 1, 2, 3, 4, 5, 6. So it's 6. So it's 12 times 10 to the 6 millimeters. That's how we would do that. Okay? Now we want to go from micro to grams. So this one, we're going the other way. 1, 2, 3, 4, 5, 6. Wow, so that's 580 times 10 to the negative 6 grams. Now I have to move that over 2 decimals, 1, 2. So that's 5.80 times 10 to the negative 4 grams, because I just took out 2 tens, okay? That's how we do that one. Okay, so if we just move it over. Okay, let's try my next one here. We want this centiliters to megaliters. So centi is here to mega, so we're going this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I think it's just 9. 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's 8. So we have 8. Okay, so we're going to go 1, 5, 7, 0, 0 times 10 to the negative 8. Okay, if we punch enter a calculator, that's moving 1, 2, 3, 4. So it's 1.57 times 10 to the negative 4. And that's it. Okay? And that's how we would solve those. So your second method is a way of doing unit cancellation. So here's a little example here, and I'll help you solve this one. So a photograph of an African elephant has a scale of 1 centimeter equals 0.6 meters. The elephant's trunk in the photograph measures 3.5 centimeters. What is the actual length of the elephant's trunk? Okay, so we have 3.5 centimeters. And we know 1 centimeter is equal to 6 meters. So I want to times that by 0.6, and then we divide it by 1 centimeter. Okay, so this is my ratio, and we just use my ratios to cancel off. So this is going to be left with 0.6 multiplied by 3.5. So that's going to be 2.1 meters. All right? So let's take a look at my next one. Reba followed a recipe for rice bean soup. 175 milliliters of beans and 650 milliliters of rice. She realized that she had not made enough of the soup and added 70 milliliters of beans to the soup. How much rice should she add? So this is another ratio one. So it's kind of like what we did in grade 8 with ratios. Okay, so of beans and 600 of rice. So we have 175 all over 650. Okay, so that's my ratio. Now this is beans. So beans is on top. Beans, rice. So we have 70. All the way is equal to 70 over x. So we have to try and solve for that. So what I'm going to do is, I'm going to end up going 70 multiplied by 670, or 650. And then I'm going to divide that by 175. Okay? So I rearrange for x. So we take a look at this. I have 70 multiplied by, then we're going to divide by, and we get 260. So she needs 260 milliliters of rice. All right? Okay. So now the next example is using a decimal analysis, and I'll show you how that one works. Okay? So it's just canceling off units in the same idea. So we want kilometers to meters. So how do we do this one? 12 kilometers to meters. Well, 12 kilometers, and we want to get rid of kilometers. And we want to put it in meters. So there are 1,000 meters per every 1 kilometer. So I'm going to do that, and I end up getting meters. So that's meters, okay? So now we look at my next one here. We have 2,730 nanometers to meters. So we have 2,730 nanometers, and we want to convert that to meters. Okay? So we have to convert that to meters. So 1 meter is equal to 10 to the 9 nanometers. Okay? We move it over 9 times. So this is going to we're going to multiply by this, just like what we multiplied here. So we're going to end up dividing that by this. So we're going to have 2,730, and these will cancel off. We're left multiplied by 10 to the negative 9 meters. And we solve this. The decimal is going to move over 1, 2, 3, 3. So that is going to be 2.730 times 10 to the negative 6 meters. Okay? So that there will be your answer. All right? And that is the way of unit analysis. Now the last one here is convert grams to mega. Okay? So we want giga to mega. So we have 0.25 gigagrams, or gigameters, to And we want to make this to, no, well, I'm just going to do this one because I think it's easier just using this table. And we move over 1, 2, 3. So that is going to be times 10. So if we have 1 giga, 1 mega is equal to 10 to the negative 3 giga. So we just divide this. I'm going to get 250, let's move the decimal 1, 2, 3 over, 250 mega. Oops, megameters, like that. Okay, because these will cancel off. Right? And that's it. Okay? Now, question number 9, last example. It says, Zimmer needed to convert 50 meters per second to kilometers per minute. What conversion will Zimmer need to know how to solve this problem? Well, first, he must know kilometers to meters to kilometers. He also must know seconds to minutes. Okay? So here, they want to finish it off. So looking at this here, I want to convert meters per second to kilometers per minute, right? So we first are going to cancel off the meters here. So every 1 kilometer has 1,000 meters. Okay? Now, every 60 seconds is 1 minute, because what I want is minutes, so 1 minute is 60 seconds. Okay? Now, we just multiply this together. This is going to give me 3,000 over 10,000, which will give me 3 kilometers per minute. And that is my solution. So hopefully you understood all this. Good luck as we try this tomorrow and work on this together. See you tomorrow.